Hi everyone, my name is Tomer and today I'm here to share our journey to better error handling in Rust. So before I start, this is me by the way. I've been coding for a decade now. I have a blog since 2017. I love trying new technologies and languages and everything coding related, so you can come talk with me about it. I started coding in Rust about a year ago, which is still considered as new. And I'm a senior software engineer at Microsoft and work on an amazing product called Defender for Identity. Look it up. Before I start with everything, I just want to say that this is not a best practice talk. This is just our journey of how we implemented error handling in our use case. I encourage you to research and do what fits best for your team. So before we dive into error handling, I just want to make sure we are all on the same page in terms of the terminology. And in Rust and in error handling in general, we usually categorize errors into two categories, into two types, unrecoverable errors and recoverable errors. For unrecoverable errors, imagine that you have some kind of configuration file, a critical configuration file, that you need to read, and if you will not be able to read it, your process will not know what it needs to do. So this, for example, might be an unrecoverable error. A recoverable error, on the other hand, will be something more like just sending an API request, and the request will time out. When the request times out, we can always try to respond. We can always try to wait for a little bit, maybe try again, maybe log the error, but this time we can respond, we can try again. So this is the difference between unrecoverable and recoverable. Rust has a pretty straightforward approach for solving this. The panic and the result, which you might have heard of. The panic is just a way to terminate the process. When the main thread panic, the process will be terminated and the program will exit with a code of 101. The syntax for calling panic, the basic syntax for calling panic, will be just calling the panic macro with the message. There are other ways to do this, but this is the most basic and straightforward one. Result, on the other hand, is here because of the assumptions that most of the errors aren't critical enough, aren't serious enough to just terminate the process entirely. So sometimes we would like, as I said, for recoverable errors to respond to it. Result is just an enum with two variants. The first one is OK, the second is error. And if we have an OK, we will get a value T. If we have an error, we will get an error E. Pretty straightforward. When we return a result from a function, we can just use this result from the calling function, the function we call the function that returns the result, and open this result and check if everything is OK. We can just continue. If we have an error, we can choose what to do with it. So we're done with terminology. Our journey with Rust begins about a year ago, as I said, where we had a huge C# project installed on millions of devices around the world with Microsoft installer that needed a performance boost. So we needed actually to deliver the executable with the operating system. And when you deliver something with Windows, it needs to perform in scale. It needs to be very lean, and it needs to be written in a native language because we can't rely on .NET Framework everywhere in the world, right? So we considered using C++ or Rust. Rust has its amazing tools, the memory features, the safety features, and C++ is a much more mature language in the world of Windows, but we didn't have any C++ expert, and we did want the Rust amazing capabilities. And when you don't have a C++ expert that starts writing C++ code inside of Windows, you're getting troubles with memory. So we did want all the Rust capabilities to work with. So we chose Rust, and we're having fun since then. So we started coding. In this talk, I'm going to take a very simple example and look at it and improve it as we go with the talk. We started coding. We have a simple read file function that tries to read a file and prints the contents of the file. We started writing a code very similar to this one, and we got panicked very quickly. So when you start writing Rust, you're not taking care of error handling, of course. You see all the examples on the internet. The example on the internet, you just see unwrap everywhere. So this is what we did. We saw this panic message, and we had we know now that the main thread panicked, that someone called an unwrap function on result type. The variant was an error, and then we got the message, no such file or directory. So let's see on the implementation of read file and see what can happen. So we have the read file function. All we need to do, all we try to do, is just to open a file, put it in the file variable, create a new string for contents as a buffer, give this buffer to the read to string function, and it will return the content size. We print the content size and return the contents. Pretty simple function. What we see here, two calls to unwrap. And we saw earlier that we have failure. We have the process terminated and got panicked because of this unwrap call. So each of these calls can cause a panic. And we know that the call was on a result function. So this means that open and read to string both return a result. So let's see how unwrap is implemented to understand a little bit more what's happening. So unwrap is just a match statement that if the value was OK, a match statement on result, we have either OK or error. So if we have an OK variant, we'll just continue. We'll just return with the T. But if we have an error, we'll call another function called unwrap failed. Unwrap failed is a pretty straightforward way to just panic with a nice message. Okay? So now we know how unwrap is implemented. And the entire thing has a big problem, even two problems. The first one is that imagine that what happens if you call the read file function from 30 different places in the code. We don't want each of the 30 different places to just panic in case we couldn't read a file. The second problem is that even if we want to panic, we want a better message. We don't just want to just see the file not found message. We want to understand what led to the error. So in this talk, I'm gonna share how we solved both of these issues and how we improved our code to be more idiomatic and more nice to read and to use. Okay, so the first thing we can do in order to improve the code is just return the result. Now we return a result. Everything compiles, everything is good. We return the result, and the caller function can handle the result, right? No, not right. We still panic here. We don't want to panic. Okay, and you'll hear me saying this a lot during this talk. We don't want to panic. What we can do instead of panicking is just open the result by ourselves. We can just do what the unwrap function did, match the result. We know that file open returns a result and read to string returns a result. And we can match this result. And now in case of OK, we just continue with the value inside. But in case of error, we will want to return this error to the calling function. And this is how we work with results most of the times. I think this is pretty ugly. I see people nodding here. Although Go developers might not agree, because this is how it looks like in Go. But just telling facts. Can anyone think of a better way to do it? A question mark. That's right. Meet the error propagation or the question mark operator. I don't know how they call it. But with a question mark, we can do the same thing, just unwrap the result, see the values inside, and decide if we want to panic. We decide if we want to return an error. We decide what we want to do in the calling function. In case of it's an error, we just return it to the calling function. In case it's okay, in case everything is okay, we just unwrapping, unpacking the value, and getting the value from inside, and continuing with it. So now we are good with our error handling in the simple function. Let's try to complicate it a little bit more. What happens if I'm changing the print function to a log function, and this log function can return a different type of error, a logging error, for example. Now the question mark will not work. We'll get a compilation error saying that the question mark would not convert this error to an IO error, std IO error, because it's a different kind of error. Anyone wants to tell what we can do in that case? Okay, I hear I hear some suggestions. The most straightforward way to solve this, and the first thing you see when you start coding in Rust, is just using the box-dine arrow. The box-dine arrow, I'm not gonna go into what box means, but when you see the box-dine arrow, it just means that you can return everything that implements the arrow trait. Everything that is an arrow can be returned from a function right now. There's an issue with this. I'm gonna touch this issue in a second, but let's do a quick recap. Panic is for unrecoverable errors. Try not to use unwrap or expect, which is the same as unwrap, basically, unless you must. Always prefer to use result to return result from your functions. And this result that you're returning, try to propagate them to the highest level you can. Because where you're in the highest level, you know more, you have more context about why you fail. So now we understand basic error handling, and this is probably most of what you need to know to make your project and your code base reliable and maintainable. So there is a problem with box-dine arrow, as I mentioned, in my opinion. The problem is that when someone calls read file, he will not know what types of error can be returned from it. And that way we miss some of Rust capabilities of being a strong typing language, right? What we can do in that case is just create our own set, closed set of errors. We just create an enum, okay? Let's call it RustLab error. This enum will contain our error variants. What we need to do in order for this enum to be error enum is to derive from error. In this case, I'm gonna derive from this error, which reduces a lot of the boilerplate. I'm not gonna go into all these error features, but look it up, it's an amazing crate. When I use this error, I have a lot of implementation, implicit implementations inside. And now all I have to do is just create my two variants. So as I said earlier, the read file function can return two variants. The first is IO error, and the second is logging error. So I'm gonna handle these two. You can see here some attributes like error, which is this error feature that helps me format and format the display of the error much easily, and the from, which will help me to convert the error I'm getting inside to my type of error seamlessly. And you're going to see in a second how it works. Another thing I can do is create my own result type, which will be the result type I'm using and returning from the function, but with an alias of this error to be a RustLab error. And now the error is alias to RustLab error, and I can just use result with the type I want to return. And I can guarantee that the only errors that can be returned from this function will be some of the RustLab errors. You can take a picture now if you want. Yeah. So now all we have to do is just return the result, the RustLab result. Let's say the module name is RustLab infra, and we can say, return this result from my function. and everything compiles again, everything works again. Any questions so far? So, let's complicate it a little bit more. Let's try to return a third kind of error, but now we don't want to add it to our error enum, because I don't want to add countless numbers of errors to my enum, because I can encounter a lot of errors during my development of my Rust library or my Rust code base. What I can do in that case is just convert this type of error to anyhow error, which is another amazing crate from the same creators of this error, by the way, that gives me a concrete type, some kind of a catch-all type that all errors can be converted to. And now I have this general error variant that I can convert anyhow error to this variant. And all I will have to do now is just map this error that I don't want to handle in my error type. I can handle this error here by mapping it with the map error function that works on result. I can run this map error on result, convert this error to anyhow error with the anyhow macro, which also comes from the anyhow crate, which gives me anyhow error back, and also helps me format the error in a pleasant way. So we solved most of your problems. We now know how to return an error or a result from our function and not to panic. We now know how to handle multiple cases of errors that can be propagated from our functions. We have our own error type that has its own variants of errors, but can also handle all types of errors if we want to. And we can tell this explicitly with the map error in that case. But we didn't solve one problem, which is understanding why the error happened, right? Let's try to take a more real-life example of another simple function. I call it read file and print JSON. What it does is very simple. We try to read file, we try to convert it to JSON, and we print the JSON. In how many places can this function fail or return an error? That's right, 2. So we can fail here in 2 places. We know that because of the question mark, right? We have 2 question marks. That means that we have 2 places that can propagate an error. But if one of them fails, I want to know which one failed. And I want to know inside of its implementation why it failed. How can I do this? Anyone has a suggestion? That's right. You're getting an A. You can use context. Context is another anyhow function that help me add context, as it sounds. I get a string literal. I put, a second. Mic check 1, 2. Okay. So I can get a context now and add this context function call on top of my result. And what it will do, it will take my error and add more information on top of the display message of this error. How it will work is that when I call the read file function, I also have implementations inside. And the reason of failure can be from the inside, and I can also add context. This is the previous read file function, but now everywhere I can see a question mark, everywhere that can fail, I can add context to these places too and understand better. So when the error will be propagated, I will get a story of what exactly led to the error, and we're going to see in a second how it looks like in production. We can also see that now I don't need to map the error anymore because the context did it for me, which is great. And in production, it will look something like this. You can see that many types and many kinds of error can be caused by trying to read the file. But here we get a story of why exactly we failed. If we take, for example, the invalid string failure, the first one, we can see that we have a message that we could not read the file and print it to JSON. By the way, this is the expect message from the main function. Why was it? Because we got an error saying could not read file. We couldn't read a file because we couldn't read it to string because the string did not contain a valid UTF-8. But we can fail with the file read for other reasons, like that we could not read it, we could not open it because we didn't find it. Or we could open it, but we couldn't convert the contents to JSON because it wasn't a valid JSON, right? Et cetera, et cetera. There can be many reasons, but now we have some kind of story behind why we failed, and we know exactly what led to the error. So a quick summary and things I want you to take from this talk. First, try not to panic. Literally, error handling can be terrifying at first. Try not to panic, and don't panic with your Rust code as well. Introducing result can help you understand why you fail better because you can respond to your errors once you introduce results. Propagation of the errors to the highest level possible will help you understand exactly what happened during the way of the propagation. If that makes sense, you propagate everything to the highest level, and in the highest level you have the highest amount of certainty and context. This error reduces custom errors boilerplate and can make your API cleaner. And anyhow is amazing for the catch-all error type and for adding context. And it's a pretty idiomatic way to handle errors. And another extra tip, try to use Clippy. Clippy has a lint called unwrap failed. Clippy is the Rust linter. It has a lint called deny unwrap. You can use this deny unwrap to deny the use of unwrap with the linter, and that way when someone tries to add an unwrap call, the linter will fail, and they will need to explicitly exclude this lint for their use. Thank you very much. You can catch me on LinkedIn or on my website. Any questions? Yeah. Here. Raise your hand again. Oh, yeah. Never mind.
Hello, thank you for your talk. And the question is simply, using context, you convert the error in anyhow. So the enum at this point is futile. You have only anyhow error everywhere, correct?
Yeah. I need to check this. I don't think so, but I need to check it.
But, okay.
Let's look at it together after this.
Yeah, my understanding is that anyhow uses the anyhow error is actually this dyn error that you started with. It is
behind
a trait
scenes,
object. Yeah. And so unless I'm very mistaken, which allows any concrete error to become this anyhow error. That's sort of how the proc macro works. At least that's my understanding. So yeah. That's why it's so flexible.
Yeah, so it's pretty simplified here, but usually the this error crate will will be more valid when you want to release your own library or crate and then give the users of this crate a closed set of errors they can, that can be handled. And anyhow is more when you want to be flexible with your errors. I try to combine these two approaches here. Yeah.
Thank you for your talk. I don't want to be harsh. I just want to point out a little thing about how to use this error. You used in the error message the
display the
the zero surrounded by
the formatting.
Yeah, and the curly braces. Yes, and that's not the best thing you can do. You should omit that in general, because when you use the unstable report, or for instance anyhow at the end, at the beginning in the main, to print out the error message, if you do that, you get the source of the error and then the source again, because in practice you're printing the display implementation, which contains the display of the source, and then the source again, because it uses the displaying of anyhow and the unstable report type uses this kind of chaining of sources in order to print them all. Sorry, just a single thing that it's
I will take a look at this. As I said, I started a year ago, and I'm here to learn more than to teach. This is just our way. Thank you.
Thank you.
Any other question?
Oh.
Yeah, thanks for the talk. And yeah, this is an open question, I guess, which is, have you found out the right balance between this error and anyhow? Because in our repository, basically we started writing, using this error everywhere, and that generated a lot of enums and a lot of variants. But at the end of the day, we ended up not caring at all, because we just bubble up the error to the top level. I mean, it's a web frame, it's a web app, so whatever. So at the end, we just return 500. This is the error. Call it a day.
So that's why I said earlier that usually when you use this error, you use it for a library when you want to expose a library and consume it from another place. So if you probably the right way to go, I don't know if you have time to do this thing, but to separate the places separate the places in your code to be crates, and then consume your crates from other places in your code, and then each crate will have its own limited enum with its values, and then they will be could be consumed from other libraries. But most of the usage I see mostly online is just using anyhow when you code inside the team and try to add context and try to explain better your errors.
Okay. Right there.
But again, I'm not an expert.
Not a question actually, but just a suggestion. As an application developer, I use the context method of anyhow, not so much to better describe the error, but where it happened, because that's what I'm propagating to an external monitoring system, like CheckMK or so. So it will probably contain something like a module name, and if I'm expecting, for example, a file from a partner interface system that's not coming, that would not be cannot read file, but partner failed to deliver that file in module whatever. So maybe just a suggestion. And I think that the name context actually implies not to add more descriptive information to the error on a technical level, but where it occurred in the entire project.
Okay, great.
So in the beginning, you shared that you were rewriting a C# project to Rust.
Yeah.
May I ask if you have rewritten it completely, or you started with replacing parts of a C# project with Rust to organically mutate it into a Rust project?
So the agent part was, we just started completely from scratch, but developing smart parts in the beginning, and we have, it was like about almost a year of just development, and now we're starting to have more and more customers being migrated from the old implementation to the old C# project to the new Rust one. So yeah, we just started completely from scratch.
And if I may segue from that, you mentioned that you had no C++ expert. Did you have Rust expert when you started out?
No. No, but we felt we had someone that from other group that did some code reviews and suggested some ideas. But the thing with Rust is that you can be much more comfortable about not ruining the computer. So yeah.
Yeah, thank you.
Any other question? Yeah, I guess that's it.
Thank you very much.